I wanted to show you how the new Freecad assembly could handle a large file with multiple parts and complex constraints. The hard part of the design is to constrain the sit boards to the curve of the leg. The modeling process is quite basic except for the circle and the bench, which involves using sketches. To begin, we will create a master sketch which will be a side view of the pergola. The drawing in the left side corner can help you to understand the design. Select the rectangular tool. We will create a side post. I use the C key to constrain the line to the axis and the D key to create a dimension of 1120, the half of the pergola length. Add a dimension of 140 mm for the width of the post. Give a height of 2500 mm for the post. With the line tool, make a separation on the bottom of the post for the height of the deck. Draw two lines, one in the post and another outside. Make the end of line coincident with the vertical axis. Enter a dimension of 225 mm. Make also two separations at the top of the post. Make them horizontal. Give a space of 200 mm for both. With the line tool, we make a construction line to materialize the center of the pergola. We align the end point to the first top beam and make them horizontal. Next, make a line from the second separation to the construction line. Next, make a circle on the construction line. Make the circle and the edge of the post tangent and end point of line coincident with the edge of the circle. With the trim tool, erase the part of the circle which we don't need. Next, make a point in the center of the post at the height of the deck. It will be used to constrain the curved leg of the bench. Make a point at the center of post at the bottom. With the 3-point arc circle, make one point on the center of the post, another at the end of the leg and another between the 2 points. Add a dimension of 380 for the height and 840 for the length. Next, select the first circle and the second half and make them equal. Make a circle concentric with the first one and define a thickness of 70 mm. Trim the excess. Do the same for the half circle of the leg. We use the C key to make the point coincident. Once the sketch is fully green, you can exit the sketch. This sketch will be useful for making the bench and the circle. It will be used also to constrain the assembly. Create a group to organize the file and name it Deck. We will model first the board one of the drawing in the right side corner. Create a cube and adjust the value to have a length of 1220, a width of 30 and a height of 200 mm. With the F2 key you can rename the cube with the dimensions like 30 by 200 by 1220. I add a point at the end of the name to avoid mistake naming when the object is duplicated. Move the cube in the deck group. Repeat the same process for the two others boards, 2 and 3, which have the same width and height, but different lengths. We will create now the floor board, which is composed of one board of 25 by 140 by 1210 and one board of 25 by 140 by 1500. You can refer yourself to the drawing in the right side corner. Now, create a new group and call it Post. Create a cube with a length of 140 mm, a width of 140 mm and a height of 2500 mm. Move the post in the folder. Next, create a group and name it Top. We will create the two beams shown in the drawing. First, create a cube with a length of 2840 mm, a width of 30 mm and a height of 200 mm. Select the two bottom sides edges and create a chamfer of 150 mm. Rename the chamfer for 30 by 200 by 2840C. Repeat the same process for the other beam, which have a length of 2100 instead of 2840. Rename it 30 by 200 by 2100C. We will model now the circle. Create a new sketch in the XZ plan. Use the tool to create an external geometry and select the two big arcs. With the arc tool, redraw the two semicircle. Draw two lines and make them coincident with the ends of the circles. Close the sketch. Create a new group and name it Bench. Move the sketch in the group. Make an extrusion of -70 mm, which is the half of the post's width. Move the extrude in the group. Now go in the draft workbench and select the mirror tool. Be sure you have the end edge snap mode enabled and select the two top points. Move the mirror operation in the group and go back to the part design. Select the mirror and the extrude and create an union. Rename the union Circle. Make the master sketch visible and create a new sketch in the XZ plane. With the external geometry tool, select the two arc circles of the bench leg and the edges of the post and the deck. Redraws the leg with the arc tool and the line tool. Trim the excess. Once the sketch is fully green, close the sketch and make an extrusion of -70 mm. Rename it leg and move it in the bench group. Now, we will create the board of the sit. Create a cube with a length of 1500, a width of 70 and a height 25. Rename it 25 by 70 by 1500. Move the part in the bench group. We will create now the path of the array. Make the master sketch visible and create a sketch in the XZ plan. Create an external geometry of the arc and the edge of the post. Create a point at the base of the post. It will be used to constrain the sit in the assembly. Redraw it with the arc tool. Give a dimension of 1 mm and 540 mm. Close the sketch. Move the sketch in the bench group. Create a new sketch in the XZ plan. Project the circle and the edge of the post. Create a point at the bottom edge of the post and redraw the arc with a dimension of 575 mm and 1005 mm. Move the sketch in the group. We will make the array on the path. So select the board and the sketch 003. Go in the draft workbench and select the path array. Change align to true. Make the align mode tangent. Change the value of the tangent vector to y1 instead of x1. Increase the number of iteration to 5. You can adjust the sketch to make a perfect fit. Move the path array to the group. Repeat the same process for the top sit. Move the new array in the group and rename it. Now go back in the deck group and select the last part. With the part select, go in the draft workbench and realize an array in the Y direction, with 13 occurrences and an interval of 150 mm. Rename the array and move it in the deck folder. We have finished to model all the parts. Mask all the part. Now go in the assembly workbench and create a new assembly. We will start to assemble the deck, so select the parts which ends by 1220 and 2070. You can follow the drawing in the left corner if you are lost. With the Join tool, select the bottom point of the board and the coincident point of the other board. Be sure to always have the blue line of gizmo of the two part in the same direction. If you have to enter an offset, it will be in the direction of the blue line. Adjust the rotation. You can use the F key to create a join. Repeat the same process for each boards. Import 230 by 200 by 2070 boards. With the Joint tool, select the center of the two face and create an offset of 366 mm. Repeat the same process for the other board. Next, import 230 by 200 by 1960 boards. With the Joint tool, select the center of the two face and create an offset of 55 mm. Repeat the same process for the other board. Now import 225 by 140 by 1210 boards. With the Joint tool, select the center of the two face. Repeat the same process for the other board. Import the array of 25 by 140 by 1500 mm. Select the center of the two face and make an offset of 10 mm. Import now 4 posts. Select the middle edge of the bottom post and the middle edge of the board with the blue gizmo in the same direction. Repeat the same process for each post. Import the master sketch. Select the bottom point of the sketch and the one of the post and make them coincident. The sketch will help to constrain the top beam. Import the 30 by 200 by 2840C board. With the joint tool, select the top left point of the beam with the blue line aligned in the Y direction and the middle point of the sketch with the blue line aligned in the Y direction. Make a rotation of -90 and an offset of -300. Import the same beam 3 times. Select the center of the two faces and make an offset of 140 mm. Repeat the same process with an offset of 1190 mm. Import now the 6 other beams 30 by 200 by 2100C. With the joint tool, select the top right point of the beam with the blue line aligned in the X direction and the top left point of the post with the blue line aligned in the X direction. Make an offset of 300. You can follow the drawing on the left side to place the other beams. Make the master sketch visible and import the circle. With the joint tool, select the bottom left point of the circle with the blue line aligned in the X direction and the corresponding point of the sketch with the blue line aligned in the X direction. Make a rotation of 90. Import a leg. With the joint tool, select the top right point of the leg with the blue line aligned in the X direction and the corresponding point of the sketch with the blue line aligned in the X direction. Make a rotation of 90 and an offset of -70. Import an other circle and a leg. Select the left bottom point of the circle with the corresponding point on the other circle. Make an offset of 1360 and a rotation of 180. Select the bottom right point of the leg and the corresponding point on the other leg. Make an offset of 1220 mm. Now go back to the bench group. Select the sketch 003 and the array of 5 boards. And create a compound. Give a proper name. Move it to the bench group. Repeat the same process for the sketch 004 and the array of 7 boards. Go back to the assembly and import the first compound. With the joint tool, select the bottom lonely point of the compound with the blue line in the Z direction and select the bottom left point of the post with the blue line in the Z direction. Make a rotation of 90. Import the second compound. With the joint tool, select the bottom lonely point of the compound with the blue line in the Z direction and select the bottom left point of the post with the blue line in the Z direction. Make a rotation of 90. Now import 2 other legs. Select the center face of the leg and the center of the opposed leg. Make an offset of -560. Repeat the same process for the other leg. Repeat the same process for the sit boards. Now the assembly is completely finished. You can try to explode the assembly. You can also create an automatic parts list. I hope this video has helped you or is at least entertaining. Let me know in the comments section what we should do next. Thanks for your attention.